Right now, at this exact moment, Earth has more than one moon. Not a metaphor, not a trick of language. A real object, a chunk of rock, is orbiting our planet right now, and almost nobody knows it's there. Scientists have been quietly tracking these things for years, and what they found rewrites everything you thought you knew about the moon you see every night. Here's what makes this genuinely unsettling. The moon you grew up with, the one that controls the tides, that humans walked on, that poets wrote about for 10,000 years, might not be alone. It never has been. Earth has been capturing and releasing asteroids since before the first dinosaur drew breath, in a cycle so vast and so slow that we've only just started to notice it. Some of those visitors lasted weeks, some lasted years, and at least one of them, drifting quietly above your head right now, may have been blasted out of the moon itself. Let's go back to September 29, 2024. On that date, Earth's gravity reached out and grabbed something. The object was called 2024 PT5. It was roughly 37 feet wide, about the size of a school bus, and it had been traveling through space as part of a group of asteroids called the Arjuna Belt, a swarm of small rocks that shadow Earth's path around the sun. On that Tuesday in late September, PT5 drifted too close. Earth's gravity hooked it, and for 57 days, from September 29th to November 25th, 2024, Earth had two moons, not two moons of equal size. The difference is almost incomprehensible. Our moon is 2,159 miles across. PT5 was the width of a house. But gravitationally, technically, it was orbiting Earth. It was captured. It was a moon. And it wasn't the first. The science behind this is called temporarily captured orbiters, or TCOs. It turns out Earth's gravity doesn't just hold the moon. It acts like a cosmic net, constantly skimming passing asteroids, pulling them in for weeks or months or sometimes years before the sun's gravity eventually tears them free again. Researchers at the University of Hawaii estimate that at any given moment, there are around 1,000 objects between the size of a baseball and a small car orbiting Earth. Objects so small and so dark we simply can't see them. They drift in, they orbit for a while, then they leave. PT5's path was particularly strange. It didn't orbit Earth in a clean circle. It looped around in a horseshoe-shaped arc, swinging close, then arcing away, then swinging back. It never completed a full revolution before the sun yanked it back into its normal path. And here's the detail that really sticks. PT5 will pass this way again. Astronomers calculate it could be temporarily recaptured around the year 2055. It may visit Earth multiple times across the centuries, like a ghost that keeps coming back to the same house. But 2024 PT5 is just the latest. To understand what's really happening, you need to go back further. The year is 2006. Astronomers scanning the sky with the Catalina Sky Survey in Arizona spot something moving in an unusual path. They name it 2006 RH120. It's tiny, maybe 6 to 10 feet across, barely larger than a dining room table, but it was in orbit around Earth. It stayed for nearly a full year, from July 2006 to July 2007, completing several loops before slipping free. Initially, scientists weren't even sure it was an asteroid. Its spectral signature looks suspiciously like the titanium oxide paint on old Saturn V rocket boosters from the Apollo program. The debate went on for years. It was eventually confirmed as a natural object, but that confusion alone tells you something important. We are still learning to read what the sky is sending us. Then came 2020 CD3, discovered by astronomers Caspar Wierschhaus and Theodore Prun at Mount Lemmon Observatory in Arizona. 2020 CD3 was roughly the size of a small car, about 6 to 11 feet in diameter. But what made it remarkable wasn't its size, it was the duration. 2020 CD3 had been orbiting Earth since approximately 2016. Nobody noticed. For more than 3 years, Earth had a second moon and nobody knew it was there. By the time scientists spotted it in February 2020, it had been quietly circling us longer than some children had been alive. It drifted away in May 2020, pulled back into a solar orbit, gone as silently as it arrived. 3 confirmed captures. Dozens, possibly hundreds of smaller undetected ones, and those are just the ones close enough and large enough for our current telescopes to find. Think about what that means over geologic time. Earth has been here for 4.5 billion years. The Arjuna Belt and the broader near-Earth object population have been cycling past us the entire time. Astronomers estimate that Earth may have hosted dozens of temporary moons per century, objects that orbited for months or years before escaping. We have no record of them because there were no telescopes. There were no humans. There was nothing but the slow and different machinery of gravity doing exactly what gravity does. You've been living on a planet that has always had visitors. You just couldn't see them. Now here's where it gets complicated, because not every object calling itself a moon is one. The most famous example is Cruithne. In the 1990s, headlines called it Earth's second moon. It was celebrated, debated, and passed around the internet as one of those facts that makes you feel like the universe has been keeping secrets. And Cruithne is real. It's a legitimate asteroid, about 3 miles across, discovered in 1986. But it does not orbit Earth, not even close. What it does is orbit the Sun in almost exactly the same amount of time as Earth, roughly 364 days per year. Because of that near match, when you plot Cruithne's position relative to Earth over time, it traces out a kidney bean-shaped path around us. From our perspective, it appears to loop around Earth, but that loop is an illusion. Cruithne's closest approach is still 12 million miles away, about 30 times the distance from Earth to the Moon. It is a neighbor in the solar neighborhood, not a satellite. The difference matters. A true temporarily captured orbiter crosses into Earth's Hill sphere, the invisible bubble of gravitational dominance that extends about 930,000 miles from Earth. Inside that sphere, Earth's gravity beats the Sun's. Objects that cross that threshold become, however briefly, genuinely captured moons. Cruithne never gets close enough. It's a co-traveler, a cosmic parallel, not a moon, but the story of co-orbitals is still astonishing in its own right. Consider 2010 TK7. Discovered in 2010 by NASA's WISE Space Telescope, 2010 TK7 is what scientists call a Trojan asteroid, a space rock locked in a stable gravitational relationship with Earth at a point called the L4 Lagrange point, roughly 60 degrees ahead of Earth in its orbit. This is the same type of relationship Jupiter has with its massive Trojan asteroid swarms, which number in the hundreds of thousands. Earth, it turns out, has Trojans too. 2010 TK7 is about 1,000 feet across, roughly 3 football fields end to end, and it has been shadowing Earth for thousands of years. Its orbit is chaotic and complicated. It actually oscillates between the L4 and L3 Lagrange points over a cycle of about 400 years. But it's there, locked in step with Earth, a stone companion we never knew we had. And then there are the quasi-moons. This is a category that sits right at the edge of the definition. A quasi-moon isn't gravitationally bound to Earth the way the Moon is, but from Earth's point of view, it behaves like one. It circles us, not because it's captured, but because its orbit around the Sun so perfectly mirrors our own that it traces a loop around us year after year. The most remarkable of these is Kamo'oalewa. The name comes from a Hawaiian chant about a celestial fragment moving independently through space, and the name is almost too perfect. Kamo'oalewa is between 130 and 330 feet wide. It orbits the Sun once a year just like Earth, and when scientists analyzed its light spectrum in 2021, specifically the way sunlight bounced off its surface, they found something that stopped them cold. It looked like the Moon. Not like an asteroid, not like a comet, like the surface of the Moon. The spectral signature matched space-weathered lunar silicates, the same type of material that coats the Moon's surface after billions of years of exposure to solar radiation. The probability of that being a coincidence was low, very low. And then, in 2024, a team of researchers published a study in the journal Nature Astronomy that went further. They identified the most likely origin point, the Giordano Bruno crater. Giordano Bruno is a 13.7-mile-wide crater on the far side of the Moon. It is one of the youngest large craters on the lunar surface, estimated to be between 1 million and 10 million years old, practically fresh in geological terms. The impact that created it was catastrophic. An asteroid roughly a mile wide struck the Moon at tremendous velocity, blasting billions of tons of debris into space. Some of that debris rained back down. Some of it became permanent scars on the lunar surface. And some of it, one particular chunk, maybe the size of a 10-story building, escaped the Moon's gravity entirely, drifted into space, and fell into an orbit around the Sun that kept it perpetually near Earth. That chunk may be Kamo'oalewa. If that's true, and the evidence is substantial, then one of Earth's current companions is literally a piece of the Moon, a fragment that was blasted free by a cataclysm a million years ago that has been circling the Earth-Moon system ever since, that we only discovered in 2016. China has already launched a mission to find out. The Tianwen-2 spacecraft is currently en route to Kamo'oalewa, scheduled to collect a surface sample and return it to Earth by 2027. If those samples match the chemical signature of lunar regolith, of moon rock, it will be one of the most extraordinary confirmations in the history of planetary science. We may have been staring at a piece of the Moon in our sky without knowing it, and in 2025, astronomers found another one. On August 2, 2025, the Pan-STARRS telescope in Hawaii picked up a faint signal, a 19-meter rock, roughly 62 feet across, moving in a way that matched Earth's orbit almost exactly. It was designated 2025 PN7, another quasi-moon, another shadow companion. Scientists at Northeastern University estimate there may be 6 more like it waiting to be found. Small rocks locked into that same near-perfect orbital rhythm, invisible to current surveys, circling us in silence. 8 confirmed quasi-moons, potentially more. Trojan asteroids, temporarily captured orbiters in regular rotation. The picture that's assembling itself is extraordinary. Earth is not a planet with one moon. Earth is a planet with one permanent moon and a constantly shifting, constantly cycling population of temporary companions that have been coming and going for billions of years. Some stay for weeks, some stay for years. Some, like Kamo'oalewa, stay for millions of years without ever truly leaving. The reason we didn't know is simple. They're small. They're dark. Our telescopes only became precise enough to detect meter-scale objects near Earth in the last 2 decades. We've been searching for extra planets around other stars while missing the rocks floating in our own backyard. The next generation of sky surveys changes that. The Vera Rubin Observatory in Chile, now fully operational, scans the entire visible sky every few nights with unprecedented sensitivity. Astronomers expect it to find dozens of new temporarily captured objects over the coming decade, confirming what the models have long predicted. Earth is not isolated. Earth is embedded in a constant, slow-moving traffic of small solar system bodies, and gravity is the mechanism that keeps pulling them in. Here's the thought that should stay with you. Right now, tonight, when you look up at the full moon hanging in the sky, you are seeing one thing, but you are not seeing everything. Somewhere in the darkness between that bright disk and the black of space, there are rocks, orbiting, circling, passing through, captured briefly by the same force that holds the oceans against the Earth, that keeps the atmosphere from drifting into the void, that makes this planet feel like it has a center. Some of those rocks are natural visitors from the asteroid belt, caught mid-journey and released. Some of them may be pieces of the moon itself, flung free by ancient cataclysms. And some, the ones we haven't found yet, may be older than anything we've cataloged, silent companions that have been circling Earth since before the dinosaurs, since before the first fish, since before complex life drew its first breath on this planet. We always thought we knew how many moons Earth had. One, just the one. A beautiful, tide-driving, sea-illuminating companion we've worshipped and navigated by for 100,000 years. We were wrong. The number has always been higher. We just couldn't see it. So let me ask you this. If Earth has been quietly collecting and releasing moons for billions of years without us noticing, what else is out there that we're missing? What's orbiting right now that our telescopes haven't found yet? Drop your answer in the comments. I want to know what you think is hiding in plain sight. If this blew your mind even a little, hit that like button and share it with someone who loves space, because these are the facts that barely make the news and they deserve to be heard. And subscribe if you haven't already. Next week we're getting into something that challenges everything you think you know about how the moon was formed in the first place, and the evidence is more disturbing than anyone expected. The sky above you is busier than you ever imagined. It always has been.